Good evening. Tonight we're going to talk about ABV and IBU exploration of beers. I'm Sakova Kiv, a data scientist who's an expert at helping companies prosper. As you know, the beer industry is highly competitive in a rapidly evolving market with a wide range of factors that can impact a company's success. At MSDS Consulting Group, we specialize in leveraging data science to help companies make more informed decisions, drive innovation, and stay ahead of their respective industries. Tonight, I'd like to share insights we've gathered from years' worth of data analysis on the breweries and beer industry and what we discovered. First, we looked at how many breweries are present in each state. In the past year, we found that the mean number of breweries for the US states overall is 11. Here we can see the states with the most breweries and the states with the least breweries, and where Budweiser market segments could be focused on. We can see that Colorado has the highest number of breweries with 47 breweries in total, followed by California with 39 breweries. On the other hand, the states with the lowest number of breweries are DC, North Dakota, South Dakota, and West Virginia, each with only one brewery. It's interesting to note that many of these states have smaller populations and may not have as much demand for beer as other states, which could explain the lower number of breweries. Overall, this plot can provide valuable insights into the competitive landscape of the beer industry and can be used to inform decision-making around market expansion, distribution, and branding strategies. Clearly, Colorado has the highest number of breweries, being the darkest shade of red. Overall, this map provides a great overview of the distribution of the breweries across the US. It allows us to see patterns and trends in the data which may not be immediately apparent from looking at the raw data alone. This information can be useful in identifying potential opportunities for growth by geographic location. Is the data missing completely at random? We addressed the missing values in each column found in our data. Specifically, we found that there were some missing values in ABV and IBU, columns for quite a few beers across different breweries. So we wanted to see the missing ABV and IBU values to get an idea as how those data points are spread across the beers overall. We can see the missing ABV values spread out over the many present ones in this dataset. This gives us confidence that suggests that the data is missing completely at random, so we do not need to include those beers with missing values in our analysis. We plotted the missing IBU values alongside the present IBU values, and the scatter plots presents the missing values that are spread out randomly across the dataset. This is good news because if the missing values were systematic, it could indicate errors in the data collection process. This random distribution suggests that the missing values is due to chance and not related to any specific characteristics of different beers in style, state location, or the dataset. Overall, the insight provides us with confidence that records aren't missing due to any specific bias or systematic errors. Moving on, we computed the median alcohol by volume, or ABV. It is a standard measure used to indicate the alcoholic percentage in beverages, and the International Bitterness Units measures the bitterness of the beer, which is primarily determined by the number of hops used during the brewing process. The IBUs are used to provide a standardized scale for measuring bitterness from 0, no bitterness, to over 100, extremely bitter. We can observe that DC and Kentucky have the highest median ABV of 6.25%, while Utah has the lowest median ABV of 4%. In terms of IBU, Maine has the highest median IBU of 61, while Wisconsin has the lowest median IBU of 19. Moreover, we found which state had the beers with the highest ABV and IBU values. So, for the ABV and IBU, we can observe the top 5 states respectively. We can see the state of Colorado takes the #1 spot with an ABV of 12.8%. On the other hand, for the top 5 most bitter IBU beers, we can see Oregon to be the winner this time with a whopping IBU score of 138. Here we can see a table of the summary statistics. Observe that we have the minimum ABV level of 0% for non-alcoholic beers, a maximum ABV level of 12.8%, a median ABV level of 5.6%, and a mean ABV level of 5.97%. Here we see a histogram of ABV values. Observe that there's a wide range of values for the ABV variable, with many of the values in the range of 4 to 7%. The distribution appears to be unimodal. Also notice the histogram is roughly symmetric, except for the long right tail, which indicates that there are some beers with high ABV values that are considered outliers, in this case a Colorado beer. In general, the ABV variable shows a reasonable range of values for beers, with most of the beers having a relatively moderate alcohol content. Now, we explored if there exists an apparent relationship between the bitterness of the beer and its alcoholic content. We can observe this relationship between the alcoholic content, ABV and IBU, of the beers. The gray dots represent individual beers and the red line represents a smooth curve fit of the data. Overall, there appears to be a slight positive relationship associated between ABV and IBU, but we can see a downward trend later since we can account for an outlier that has a high ABU but lower IBU value. As the alcoholic content of the beer increases, so does its bitterness, as indicated by a general upward trend of the red curve. However, the relationship is not very strong, as there is quite a bit of variability in the IBU values for any given ABV value. This suggests that while there's some relationship between ABV and IBU, other factors such as the type of beer, brewing methods, and ingredient choices are also important in determining the bitterness of a beer. Furthermore, we wanted to identify whether there is a relationship between ABV and IBU values and its classification as an IPA or an ale. To answer this question, we used a machine learning technique called K-nearest neighbors to classify beers as either an IPA or ale based on their ABV and IBU values. To do this, we first ran this analysis multiple times with different training and testing data sets and different values of K, which is the number of nearest neighbors used in the classification. Here we happen to see our best K value is 5 with an accuracy rate around 86%. The confusion matrix here is a 2x2 table that summarizes the performance of a classification by comparing its predictions to the actual labels in the test data set. Here, the rows correspond to actual classifications and the columns correspond to prediction classifications. Here we treat ale as being the positive classification and IPA being the negative classification. The four possible outcomes are true positive, false negative, and true negative. We can observe that the statistical performance results of this K&N model accurately classifies a beer as an ale or IPA with an 84% accuracy rate, which is pretty good, so we are confident that this machine learning K&N model is correctly classifying the beers based off the associated relationship of the ABV and IBU. We can visualize the decision boundary for the K&N model, which is a straight line that separates the different types of beers based on their ABV and IBU values. The K&N model uses the boundary to classify new beers as either ales or IPAs. In general, we can see that IPAs tend to have higher IBUs and ABV ranges. But there seems to be also some overlap between the two groups. The decision boundary is set in such a way as to maximize the accuracy of the K&N model in classifying the beers. We can infer from this heat map that Budweiser could adjust their beer offerings to include more IPAs and ales, particularly those with high IBU values and average IBUs respectively, to meet customer demand and capitalize on this popular beer style. In general, IPAs have higher ABV and IBUs than ales, but sometimes there is an overlap of these characteristics. Budweiser could design new beers based on these characteristics and classify their beers as IPAs or ales and market these in states or regions where the demand is high for these styles. I hope this information is useful in your decision-making processes. Now, thank you for joining me today for this presentation. Again, my name is Sakib Akib, representing the MSDS Consulting Group, and I hope you found it informative and engaging. If you have any further questions or would like to discuss the topics covered in more detail, please don't hesitate to reach out to me. You can contact me via email at soc2000.kiv@gmail.com. Thank you.